We usually write off liver disease as, well, a consequence of lifestyle, right? Like metabolic wear and tear. Yeah. We think of decades of bad food or maybe too much alcohol. But what if I told you doctors are diagnosing fatty liver disease in infants? I mean, babies less than 3 months old. It is a startling reality to wrap your head around. And for our deep dive today, we have a fascinating 2026 study from the American Journal of Physiology, Endocrinology, and Metabolism, which really focuses on this exact issue using a neonatal pig model. Exactly. And our mission today is to uncover this metabolic paradox they found. It actually challenges everything we thought we knew about how liver disease develops in neonates. It is wild. Let's unpack the context first. We were looking at pediatric steatotic liver disease, or SLD. Right. Usually when we see this condition in adults, the logic is pretty straightforward. The liver is overwhelmed by obesity and it just slows down. It gets sluggish, exactly sluggish. But with these infants who are obviously not obese adults, that logic falls apart. So to figure out why, the researchers used neonatal pigs. Yeah, pigs are the gold standard here because their growth and metabolism are incredibly similar to human infants. They wanted to test how formula composition actually affects the liver, especially comparing long-chain fatty acids with medium-chain fatty acids. NCFAs, right, NCFAs. I see NCFAs everywhere, like MCT oil, coconut oil. They are heavily marketed as quick energy. Oh, absolutely. The idea is they bypass standard digestion rates. They are supposed to be the good fats. But in this experiment, the results for the MCFA formula were pretty catastrophic, right? Catastrophic is the right word. The pigs fed the MCFA formula didn't just get a little sick. They developed rapid steatosis, so fatty liver, by day 7. Just 1 week. And by day 14, it had progressed to steatohepatitis. Wow. Yeah, that is active inflammation and actual physical liver injury. Okay, so this quick energy fat basically destroyed their livers in 2 weeks. It did. And here's the part where it gets really interesting for me because I assumed the liver just couldn't process the fat, like it got clogged up like a drain. Well, that is the standard assumption in the medical field, a failure of oxidation. We assume the liver just stops burning fat efficiently. Right. But this study found that metabolic paradox we mentioned earlier. The livers in these sick piglets were not sluggish at all. They were actually hyperactive. Wait, the liver's full of fat. Surely it is not burning it. It was burning fat at record speeds. The researchers found sky-high levels of beta-hydroxybutyrate in the blood plasma, which are ketone bodies. Exactly. Ketones are basically the ash left over from the metabolic fire. It proves oxidation is happening. Right. Plus, they saw a massive upregulation in fat-burning genes, specifically CPT1 and ACOX1. So those genes are essentially screaming at the liver to burn fat. Yes. Okay, so the liver is incinerating fat as fast as it can, but it's still getting fatty. That does not add up. If I am burning through my fuel tank, the tank should be empty, not overflowing, unless you are filling the tank faster than you can drain it. The synthesis. Exactly. While the liver was ramping up oxidation, it was also drastically upregulating lipogenesis. It was making new fat. Making new fat while burning the old fat. Yes, the genes responsible for making new fat, like FASN and SREBP1C, they were spiking simultaneously. So it is like, imagine you are in a rowboat that is taking on water. You grab a bucket and you start bailing, right? You are bailing faster than you have ever bailed in your life, working at maximum capacity, but someone has aimed a fire hose directly into your boat. Yes. The bailing is the oxidation. The fire hose is the synthesis. You cannot bail your way out of a fire hose. Yeah, it is the perfect analogy. The liver is not lazy here, it is drowning. The influx simply overwhelms its capacity to oxidize. So what does this actually mean for treatment? Because if a doctor sees a fatty liver and assumes, hey, this baby has a slow metabolism, let's boost it, they're just yelling at the guy with the bucket to bail faster, and it might be totally useless. The liver is already redlining. This study suggests that for this specific nutritional type of SLD in neonates, we should not focus on boosting metabolism. We need to turn off the fire hose. We have to stop the synthesis of new fat. It really flips the script. It is a high energy, high turnover disaster, and it serves as a stark reminder that infant metabolism is a very unique beast. We absolutely cannot just treat babies like tiny adults. It definitely makes you look at those healthy fat labels a bit differently, I'm sure. I mean, if the liver is burning at max capacity and still failing, maybe easy to digest is not always a good thing for an infant. It is definitely something for you to think about the next time you see a quick energy marketing claim. Thanks for joining us on this deep dive.